In this lecture, we're going to talk about solving and using linear systems of equation, which are also known as simultaneous equation. So first we want to start with the definition of what are we going to be using in this lecture. What is a linear system? So as the name implies, in a linear system, all the variables that we're using are linear. They're only raised to the first power. We have no square roots, we have no square, we have no cube, we have no sines and cosines. We only have variables to the first power involved. And the variables that we're using, we're only adding and subtracting them with each other. They're not being multiplied by each other. They're not being raised to powers of one another either. So you've seen these types of systems before. Again, they may have been called simultaneous equations, but they could be examples like this, where we have two equations for two unknowns. Now in this example, we have x1 and x2 that we don't know, and there's going to be a solution for x1 and x2 that makes both of these equations simultaneously true. Now in this case we have as many equations as we have unknowns, two unknowns and two equations. We would call this a 2x2 system, and there's going to be possibly a unique answer, but there's not necessarily always a unique answer for when we have the same number of equations as we have unknowns. And then we can have a larger system like this, where we have three equations, x, y, z, and we have, or three variables, x, y, z, and three equations also. So again, we have the same number of equations as unknowns in this second system down here, which means there may be a unique solution, an x, a y, and a z, that makes this three equations simultaneously true, but we're not guaranteed of that. But when we're talking about linear systems, we don't necessarily have the same number of equations as we have unknowns, but we see in both of these little examples here that the unknowns, x1 and x2 in the first system and xyz in the second system, only are raised to the first power and are being added and subtracted with the other variables in the system.